Good morning, everybody. Today we're going to go over 2.6 notes that covers rational functions and their graphs. Before we get started, I just want to talk about some of the things we were expected to have today. For example, the quiz today, I'm going to go ahead and cancel that for now. For my Group 1 kids, my Group A kids, expect that quiz on Monday when we go virtual with you. And expect it Monday. I will post it on Teams with a form or some sort, but as of right now, it will be postponed until Monday. And I will let you know Monday if I was able to get it working or not. But there's no quiz today. And then for my Group B kids, if you happen to be watching this, you will be on Monday like normal with a quiz in hand ready to go. Okay. Secondly, your Unit 1 retake practice test is due today at 5 p.m. So if you need to get that covered, please do. You have a maximum of 80% you can earn on this practice test. I understand that it says practice test and it's a little bit confusing with the wording, but that will be what is changed in the grade book if you got less than 80% or didn't do your test altogether. So that is the assignment that you need to complete in order to get your credit back. It's posted in Teams. All work needs to be shown. And you will receive credit. No work, no credit, plain and simple. This is the last deadline for that assignment, so get it in. If you miss the deadline tonight at 5 p.m., then there are no excuses. We weren't intending to expand the deadline here, but we did for you, so make sure that you are taking advantage of that and getting it done on time. All right. 2.6 is the last section we are going to cover before your first in-person test. So next class, we will have a test on all of Unit 2 that we have covered so far. All right. Now, it's not going to be an in-person test the entire class period next week. We are going to take the test for the first maybe 45, 50 minutes, see how we're doing. And then we still have a lesson to cover after that. So be prepared. Make sure you're ready for the test. I believe the assignment tonight, let me double check. The assignment that's going to get posted. Let me look here. The assignment might just be 2.6 homework. Yes, okay, so it is just 2.6 homework. However, if you review all of our homework that we've covered so far in Unit 2, then you should do just fine on the test. If I get around to it later today, I will see if I can post a study guide for the test as well so that you guys can be better prepared on that end. But that won't be mandatory. That will be for you to cover if you'd like. Otherwise, review for your Unit 2 test through your notes and your homework that we've completed so far. All right. So let's get started on 2.6. We're talking about rational functions and their graphs. Right? 2.6 is still considered to be a review unit for you, or review section for you guys while we go through this from Algebra 2. All right. If there's any questions at all through this video, just send me an email or comment on Teams and I'll get back to you throughout the day and we'll go from there. All right. So as we read through the first set here, we talk about rational functions. Rational meaning that it's the quotients of the polynomial function. So think rational, think like a fraction type of thing. All right. We have a function, p of x, or f of x equals p of x divided by q of x. So there are two parts to a rational function. Then we have domain of rational functions. All right, we've talked about this in Unit 1. We've talked about this in Unit 2. We're going to talk about it again. So, domain of a rational function is the set of all real numbers except the x values that make the denominator 0, okay? That is important. So if I had anything in the denominator, like if I have a function like this, my domain is going to be all real numbers except for whatever will make that denominator 0. So in my case, that would be a 5. And my domain for this function would be all real numbers except x equaling 5. Or if you do your interval notation, it would look like negative infinity to 5 with parentheses, union 5 to infinity. That is what the domain would look like. And it's not letting me close off with parentheses there. And there we go. That's a big set of parentheses. Anyways, domain of a rational function. Okay. Then we have vertical asymptotes. In order to find a vertical asymptote, we first have to factor the denominator. Again, we have to find those restrictions. If there are no factors that match in the numerator and the denominator, then the vertical asymptotes are what makes the denominator equal to 0. All right? And if you remember, any factors that matched were called wholes. Okay, we'll have some examples like that as we go through the notes here. Usually wholes are what you guys tend to remember the most. So we will go over that and make sure we remember as we go through the notes later today. Otherwise, if nothing matches, we know that we are working with vertical asymptotes. All right. So with all this in mind, let's go ahead and get started on question 1. Find the vertical asymptotes, if any, of each rational function and state the domain. So I'm going to look at question 1. I have f of x equals x divided by x squared minus 9. All right. Well, in order to get started, I want to convert it into factored form, everything into their most basic form. So I'm going to keep the x in the numerator. And when I factor the bottom denominator, it's going to be a difference of squares. So I have x plus 3, x minus 3. All right. You can still factor this, saying what multiplies to give me negative 9x squared and adds to give me a 0x because there's no middle term. You'll find that that's a positive 3 and a negative 3. And those are the same two factors that I just used in my two sets of parentheses. All right. With it factored now, we are going to look straight into our denominator. Nothing is going to cancel because no two factors on top match with the bottom. All right, so now that I look here, I know that at x equaling negative 3 for my first set of parentheses, and at x equaling 3 for my second set of parentheses, those will be my vertical asymptotes. Because it's in the denominator, it follows the rule that I just read, and no factors match in the numerator and the denominator. So in this case, x minus 3 and x plus 3 are my vertical asymptotes that make the denominator equal to 0. All right. Making sure that on your vertical asymptotes, you're always writing x equals this, x equals that. Okay. It's a vertical line, so it needs to be x equals functions. And the last part to the directions were to talk about the domain. So again, this was on your Unit 1 test or on your practice test if you're going to go and redo it. All right, so when I know the domain, I have to pay close attention to these restrictions coming from the denominator. So I'm going to have negative infinity to negative 3. That was my first restriction. Union negative 3 to positive 3. Union positive 3 to infinity. There's quite a bit of intervals on this one, but it is considered to still be the domain. All right, the only reason we have so many is because there are two restrictions. Okay, let's go ahead and jump down to question 2. We'll do the same thing. We're going to factor it immediately, so x plus 3 will stay in the numerator. And in the denominator, you'll notice that it's the same exact thing, so it's going to be a difference of squares again. Same as number 1. okay? But this time, if you notice, oh my goodness, if you notice, our x plus 3 factors are going to match in the top as well as the bottom, okay? When they match, remember this is going to be called a hole. So as soon as I see that they're going to match, I'm going to say there's a hole at x equals, and go ahead and look where x has to be, what x has to be in order to get this to be a 0. So x would have to be a negative 3. So there's a hole at negative 3, okay? When we talk about holes, they're no longer considered to be vertical asymptotes. So the only other factor here is going to be considered my vertical asymptote. It's in the denominator, it's factored. I just have to be aware that when I solve for x this time, it's going to be a positive 3. And that, my friends, is your vertical asymptote. You have a hole at negative 3, but a vertical asymptote at x equals positive 3. Okay? As soon as I know that, I can go and make my domain again. And when you do your domain, holes do count. All right? Remember, if you have a graph with a hole in it, it's going to be an open circle at that point, which means it's not included on the domain. So we have to remember that. So when I go to my domain, you will notice that it's going to be the same exact domain as question 1. All right. Negative infinity to negative 3, union negative 3 to 3, union once more from 3 to positive infinity. And that is question number 2. All right. Question number 3, however, if you look closely, and if we wanted to factor the denominator, we would say what multiplies to give me a positive 9x squared and adds to give me 0x, because there's no middle term. All right. Your only options to get a positive 9 are a positive 3 and a positive 3, or a negative 3 and a negative 3. But when I use either one of those in my second function, solving for 0x, it's never going to happen, okay? And because of that, we know that our denominator is not factorable, okay? And what that means is that if it's not factorable, we don't have vertical asymptotes this time. So we're going to say none. And my domain is going to be all real numbers, because there's no such number that's going to make my denominator a 0. Okay. Another thing to remember is that even if you think of negative numbers, a negative squared is still going to give us a positive out. So my denominator is never even going to be negative. It's always going to be positive as well. Okay. It's not really important to note here, but I just want to go over that in case it comes up later on in our trig semester. All right. So vertical asymptotes, we are focused on the denominator, factoring the denominator. When we move into horizontal asymptotes, these rules are the most important. Okay, you will need to have these rules memorized for your test on, if you're a group A day, it will be the 17th, and if you're a group B day, it will be the 18th, so Thursday and Friday next week. So when we look at these rules, we have to pay close attention to the variables that they're using. Okay, so for horizontal asymptotes, let f be the rational function given by this, f of x equals ax to the n, divided by bx to the m. For rule number 1, if n equals m, the line y equals a divided by b is the horizontal asymptote. Okay, notice the letters a and b are the coefficients in front of my x variables. All right. In this second one, if n is less than m, so we're talking about the exponents, then the line y equals 0 is the horizontal asymptote. Doesn't matter what n or m are, as long as n is less than m, then I have y equals 0 as the horizontal asymptote. And last but not least, if n is greater than m, then the graph has no horizontal asymptote. Okay. Now looking at this, it looks a lot to remember, but the practice of these functions and practicing horizontal asymptotes is what's going to get us to remember it the most. All right. Notice how all three of these start with n's and m's. So as we go through these notes, we are focused on the exponents of my x variables. Once I know those exponents, then I can use those three rules to determine what's going to happen. All right. So if I go ahead and look at question 1, find the horizontal asymptote, if any, of the graph of each rational function. Okay. Well, notice there's no graphs, so we need to use our rules. All right, so if I look at my x terms here, let's go ahead and highlight. My exponents on those x's are 2. Okay, both of them are 2 in fact. So I know that n is going to equal m in this scenario, which is going to make us use this rule up at the top. All right, that tells us to take the coefficients in front of my x variables, and that will be my horizontal asymptote. So if I go ahead and simplify those, I know that I have a horizontal asymptote at y equals 9 divided by 3, but we can, of course, simplify that to be y equals 3. That is my horizontal asymptote as I solve this. Okay, that's all it's needed. You focus on the exponents, determine if they're equal to each other, less than, or greater than, and we go from there. All right, we'll go to question 2. Remember to review the top ones, the rules as we go if you need to. We'll do the same thing. Look at the variables. Focus on their exponents. On the numerator, the exponent is technically a 1. So right now, I know that 1 is less than 2. So if I go back up to my rules, I'm going to have to use the second rule, if n is less than m. Well, if that's the case, then the line y equals 0 will be my horizontal asymptote. So I'm going to say a horizontal asymptote at y equals 0. Strictly because my n value, the top exponent, was less than my m, my bottom exponent. Okay, the rules apply here, so let's use them. Last but not least, we have x cubed and x squared. If we look at those, we know that cubed is greater than squared. So we go back up, we look at the rules, and this time, since I had a greater than, I know that there are no horizontal asymptotes. And I'm abbreviating it this whole time. If you choose to abbreviate your vertical asymptotes and horizontal asymptotes on your test, that's totally fine. I know what you're talking about. Okay, so we need to use those rules. And we're going to take those rules and basically go full circle and use them for our graphs. So we have our graphing irrational function steps. So step 1, just like we did in the notes, find the vertical asymptote. Step 2, find the horizontal asymptote. Step 3 kind of goes with step 1 because vertical asymptotes and holes kind of go hand in hand. So step 3 and step 1 kind of go at the same time, but we can do step 3. Find the hole in the graph, if there is one. It's not always going to be the case. And step 4, find the x-intercepts. We've done this. Okay, we'll get some more practice on that. Step 5, find the y-intercept. And 6, pick additional points if necessary. Okay, now remember, we have graphing calculators or we have Desmos or that TI-84 or Calculate 84 app on our phones. Okay, so we can type those and use those calculators to help us. All right, but I'm going to use the steps. If you want to use the calculator to check your work, I would highly suggest that, but don't take it further. We still want to see all of our work going into these problems. All right, so the first one is to find our vertical asymptotes. When we do vertical asymptotes, we are focused on the denominator. So what's going to make that denominator 0? If I have x minus 1 and I set it equal to 0, I need to add 1 to both sides, so x equals a positive 1. All right, so I have a vertical asymptote at x equals 1. Step 1 is done. All right, as you know things, we can obviously go in straight to our graph and work those in. So if it's a vertical asymptote, I want to use dashed lines. And since it's at x equals 1, I'm going to go on my x value of 1 and draw a vertical line, vertical dashed line, to show it's an asymptote at x equals 1. That part's done. Now I'm going to move to step 2, where it talks about a horizontal asymptote. Again, when we look at horizontal asymptotes, we're focused on the exponents. On this case, we have exponents of a 1 up top and a 1 down below. So right now my exponents are equaling one another. Therefore, my function for my horizontal asymptote has to be the coefficients out front. So on the numerator, I have a 2, and in the denominator, I have a 1. So if we simplify that function for y, it's just going to be y equals 2. Again, you know this bit of information, so let's go ahead and look at the graph and draw a horizontal asymptote, this time at y equals 2. All right, and if it's a horizontal asymptote, we want to be drawing a horizontal line, finding 2 on my y-axis, and graphing a dashed line from there. All right. Step 3 regards holes. Well, if you look back, it was already factored. There's nothing I can take. All right, I can't look and say, well, these are all the same, so they must be holes, okay? They're not the same because there's still a 2 out front. So unless you can factor that 2 out and still have them be the same, they are not holes. So in this case, we have no holes. So we don't need to worry about that on our graph, okay? Step 4 is going to be finding the x-intercepts. Okay, well, for x-intercepts, we are just focused on the numerator. Okay, because when we find the x-intercepts, we're finding where the function is 0. Okay, so if I took this whole function and set it equal to 0, let me go back there we go, and set this equal to 0, if I cross multiply and I take this x minus 1 and multiply it by 0, what's going to happen? You're going to be left with just 2x minus 1 equaling 0. So when we do the x-intercepts, that's why we're only focused on the numerator, because as soon as I cross multiply that denominator, it's going to go away anyways. All right, so if I solve for my x-intercepts, I'll do my work over here for you. And I'm going to add 1 to both sides. And then I need to divide by 2. My x-intercept for this graph will be at x equals 1 over 2. You know this bit of information, so let's graph it. I know it's a fraction, so we're going to try our best to make it a good point. It's going to be about right there on my x-axis at about 1/2. Okay. All right, step 5. This time we're going to do our y-intercepts. So if you remember your y-intercept, it's where your x is 0. So all we have to do is plug in a 0 for my x. So in my function, every time I see x, I'm going to replace it with 0. And when I solve, I have 2 times 0, which gives me 0, and a -1 over a -1, which ends up giving me a +1. So on my y-axis, at +1, I'm going to have my point. Okay? And the last thing is, if you need more points, you can test them. All right, so right now, before I get to step 6, I'm going to show one of my graphs. Okay, rational functions are going to be 2 parts. So right now, if I connect the dots that I have here, it's going to look like this. And everything is approaching your vertical asymptote and your horizontal asymptote. They're never going to cross over like that. All right, that's never going to happen. So there's one part, and then the second part's going to be the exact same thing on the opposite side. So we want to have a graph in that corner, all right? But we don't want to just do a random sketch because it could look something like this, and that's not completely true. So what we want to do is to go to step 6, and we want to test a point. Okay? Now the good news is we can test any point, but let's think about it for just a second. I know that I need to be in this section here. So when I test a point, I want to test those x values that are also in that section. So it wouldn't really be wise of me to test x equaling 1 because that's part of my asymptote. It's not going to work out for me. But it might be wise for me to test x equals 2 and go from there, okay? If we get 2 points, great. If we get more points, we're just making it a more precise graph. All right, so let me clear this for us. And I'm going to test, like I said, x equals 2. And all we're going to do with that is we're going to plug it in to my function and work it out. So we have a 4 minus 1 over 1, which is going to give us a 3. So at 2, 3, I will have a point. So I can graph that. Okay? And then the other point is just to graph another test. So I might test x equals, let's say, 3. Okay, I'm going to steer clear from any fractions just because I don't want to work with fractions. That's just my preference. So I'm going to test x equaling 3. And I'm going to do the same thing. F of 3 equals 2 times 3 minus 1 divided by 3 minus 1. Gives me 6 minus 1 divided by 2 and 5 over 2, which is roughly 2.5. So at 3, 2.5, I have my other point. So I go to my graph, and I'm going to plot a point at 3, 2.5. All right. Now again, I started this portion of the notes talking about using your graphing calculator. So if you type this in your graphing calculator right now, you should get a graph that looks like this. But be very careful. If you have those newer TI-84s, you can make the fraction out of it and it will be fine. If you have the older version, the like bulkier type of calculator, or you're using the app, or you're using Desmos, or what have you, if you don't get a function that looks like this when you go to graph, double check and make sure that your numerator is in the top and your denominator is in the bottom. And if you have to add an extra set of parentheses around them in order to get that picture, you may do so, okay? The extra set of parentheses is just telling the calculator that this is strictly your numerator and the bottom is strictly your denominator. Okay, especially if you have to just write it in one single line. Okay, so that's all we have to do for question 1. All right, vertical asymptote, horizontal asymptote, x-intercepts, don't forget your holes, x-intercepts, y-intercepts, and then any additional points that we need later. So let's go ahead and try question 2. Looking at question 2, you guys can try this one on your own. All right. Reference my notes that are posted in Teams if you would like the answer to this one. There are going to be 3 total lines on this problem, so make sure that your graph matches mine that are posted in Teams, and we can go from there. But the same steps apply. Look for your vertical asymptote, so that means we need to factor the denominator. Then your horizontal asymptote, look at those rules on your exponents. Check for holes. I will tell you that this question has no holes. X-intercept, y-intercept, and then any additional points from there, okay? And you'll notice that the reason we have 3 lines on this one is because we will have 2 vertical asymptotes when we solve that denominator, and we will also have 1 horizontal asymptote when we solve. So when we separate everything, you will have, I'm just doing a rough sketch here, this isn't going to be the final answer. You will have something that looks like this with all of your asymptotes, okay? And when it looks like this, that means we're going to have some portion up here, some portion up here, and then the third is going to be a parabola. And it's going to look something like this, okay? So make sure that you're testing good points, getting enough in each section that you need, and going from there. Again, my notes are posted in Teams already if you'd like to double check and see how we're doing from there. I'll go ahead and do question 3 with you guys though. Okay. Question 3 is going to end up looking pretty similar to question 2 up above. So when we go and we start factoring this, again, step 1, vertical asymptotes. We're focused on the denominator. So I'm going to go and I'm going to rewrite this, -4. And we have, when we factor, well, multiplies to give me -6 and adds to give me -1. We have x minus 3 and x plus 2. Okay. With that factored, I now know that my vertical asymptotes are at the opposites. So one is going to be at x equals +3, and the other one will be at x equals -2. So I go to my graph, make sure I line this up correctly here. -2 and +3. So there's my vertical asymptotes. Then step 2, I have horizontal asymptotes at y equals, remembering horizontal is always y equals. Okay, and when I use my rule here for the exponents, I don't have an exponent in the top. However, if I write it in, my exponent on x is going to be considered a 0 because anything to the 0 power is going to give me 1. So if you ever see a constant in the numerator, we're going to use the 0 as the exponent. So right now I have a 0 up top and a 2 down below. So I know that 0 is greater than 2. Therefore, my rule that I'm going to use is that my horizontal asymptote is at y equals, oh my gosh, why did I say 0 is greater than 2? It's too early in the morning, obviously. Okay, 0 is less than 2. So when I go to use my rule, it will be y equals 0 that I'm going to choose. So I go to my horizontal axis, asymptote, and I graph from there. So this is what my graph will look like. I see I have 6 sections total, but I know based off of question 2 up above that I'm going to have 3 different portions when I go to make my lines. Okay. So I have step 3, I check for holes, nothing's going to match, so there are no holes. Step 4, I check for x-intercepts, okay? Remember when we do that, we're going to say -4 divided by x squared minus 6 minus x squared minus x minus 6. We're going to set that whole thing equal to 0, but when I cross multiply this times 0, it's going to just cancel. And I'm left with -4 equaling 0. There's nothing any longer that I can solve for. So I'm going to make note that there are no x-intercepts, because there's no x value up in the numerator that I can solve for. Okay. Step 5, I'm going to find my y-intercepts. I can do this one. All right, so step 5, I'm going to plug in my zeros for x. So I have f of 0 equals -4 parentheses, or divide by 0 squared minus 0 minus 6. I simplify everything and I have -4 divided by -6. And when I take out the negatives and I find a common denominator between the two, I'm going to take out a 2 from the top and a 2 from the bottom. So I know that I have a y-intercept at 2/3. So I go to my graph, I look closely to 2 divided by 3 on my picture, on my y-axis, and that's going to be just underneath 1 on my graph. Okay. So right now, if we remember, your parabola is always going to be in the middle between your 2 vertical asymptotes. So this time my parabola is going to go upwards. Okay, now I will admit I did use a calculator on this one just because it was quicker for me to see what the graph would look like. But at the end of the day, I could have also taken question 6 or section 6 of graphing and plugged in a bunch more values, such as x equaling 1, or going down in the corner saying x equaling 5, or x equaling -5, to get an idea of each section where my graphs are going to be placed. All right. Now they're just sketches. We're more focused on the asymptotes and the holes and the intercepts. All right. The added points are just making our graph more precise. So I can use a calculator. I'm not going to be very picky about this. But if you use a calculator, it should look something like this at the end. So you have a parabola going up in the middle, and then the 2 other sections are in the corners looking like this and approaching your intercepts from each side. All right, double check the calculator. Again, when you do type it in the calculator, if I typed in the original function here, make sure that you're adding an extra set of parentheses if you have that type of calculator that's not going to graph it correctly. Okay, if you can't distinguish between your numerator and denominator on your calculator, you need to add that extra set of parentheses. All right. And the last section of these notes is slant asymptotes. Okay, definition is listed here. Slant asymptotes is the graph of a rational function has a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator. Okay, so that's the only time we're going to have a slant asymptote. Is if the exponent is exactly 1 more than the exponent down below. So to find the slant asymptote, we have to divide by synthetic division. So we're using what we learned last class to find slant asymptotes. But before we do synthetic division, we have to make sure that this rule applies. Otherwise, we're just going to waste our time. Okay? So when I get started on question 1, I'm going to check the exponents. So I have a 2 up top and a 1 down below. If that were to actually be written in, that would be a 1. So I know that 2 is exactly 1 more than 1. So yes, there is a slant asymptote. So I can continue. Okay. If we remember from synthetic division, I solve that denominator, that factor, so I know that I have a 0 at x equals 1. So that's what I'm going to use when I prepare my synthetic division. Take my constants from the numerator, so I had a 1 here and a 1 at the end, but remember, I have to remember my placeholders. So there's really an x squared plus 0x plus 1. Don't forget your placeholders. So now I can take all of my coefficients, plug them in, and start synthetic division. Bring down my 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. And I have a 2 at the end. Okay. So my slant asymptote, if I were to rewrite this before I actually get to my slant asymptote, this function would be y equals, drop my exponent by 1, so I have an x to the first, plus 1, and then plus that remaining value, 2, divided by x minus 1. So that would be my rewritten function when I divided by x minus 1, but when I do my slant asymptote, I am only focused on this section here. I don't need that remainder. So my slant asymptote is only going to be y equals x plus 1. Okay, that one was kind of fast. Let's try number 2, see how we're doing. So to get us started, if it's asking about slant asymptotes, we need to verify that it is a slant asymptote, or it has a slant asymptote. So I look at the exponents. I have a 2 up top and a 1 down below. It's exactly 1 above, so that's good. I can say that yes, there is a slant asymptote. And then I can continue. If I solved this, it would be a 2. I'm going to take that 2 and use it in my synthetic division. Look at all the coefficients up top on my numerator. I have a 2, a -5, and a 7. And then I start my synthetic division. Bring down my 2. 2 times 2 is 4. -5 plus 4 is -1. -1 times 2 is -2. And 7 minus 2 is 5. Okay. Remembering on my slant asymptote that I don't necessarily care about the remainder. I'm just focused on the values, the coefficients. So when I write it, I'm going to have 2 drop down by 1 exponent, so it's just going to be 2x minus 1. And I have my slant asymptote. And last but not least, when I get to question 3, again, you're always checking. So find the slant asymptote if any of the rational functions. So if I look at question 3, my exponent up top is a 1. My exponent down below is a 2. Is that allowed? Is 1 exactly 1 above 2? No. It's less than, so it's not greater. So I have no slant asymptote. So we can't synthetically divide or find the answer. I'm done with no slant asymptote. Okay. Again, we can go back, look at my posted notes on Teams, see what we missed, see what we need to get a refresher on. There's more comments on those notes as well if you need to see those comments. But definitely go back and check those for question 2 and do those on your own for notes. All right. As a reminder, your Unit 1 practice test is due tonight if you wanted a higher score of an 80% maximum. So be sure that you are submitting that with your work. I'm not going to contact you if there's no work. So post it. If you think that it didn't post or you're wanting to make sure it did, just send it to me in an email as well. Okay, I've had teams kind of kick some kids out every once in a while, so if there's some sort of glitch, let me know. But 5 o'clock is the deadline, especially when today you have a digital day. So make sure you are doing that today. Okay, please post it by 5 o'clock. No other excuses. All right. For my Group A kids, expect your quiz on the digital distance portion on Monday. And then if any of my Group B kids are watching, you will still have your in-person quiz on Monday. And Unit 2 test on Thursday and Friday. I will post some sort of study guide for that as well, heading into the weekend. All right. You guys have a great weekend.